Hello dear friends, this is Srinivasan, who is having more than 40 years experience in the construction industry, trying to present you a small presentation on how to measure bricks, cement and sand quantities in the brickwork. It is a civil conclave presentation. This image shows how the brickwork has been carried out, how the mortar joints have been filled up. Now let us go into the presentation. In this presentation, we are going to talk about it, the quantity of the brickwork in calculations, types of bricks, bricks in construction. Bricks is most commonly used building material and used for constructing walls, roofs, paving floors, etc. The term brick is referred as a rectangular unit composed of clay. Bricks are available in different classes of sizes. The sizes of the brick may vary according to the region. To know about brickwork calculation, let us learn the basic of what is meant by a brick. Bricks are usually classified into two types. They are called as fired bricks and non-fired bricks, and they are further classified as first class, second class and third class bricks. Composition of the brick. Alumina. A good class bricks consists 20 to 30% of alumina. Excess of alumina in a clay makes the brick crack or rap while drying. Silica. Bricks are made with 50 to 60% silica in it. Excess of silica makes the bricks to brittle. Lime. Brick consists of 0.8 to 2% of lime in it. Excess of lime in brick may cause to melt and distort while burning. Other gradients of the bricks are magnesium, sodium, potassium, manganese and other oxides, that is iron oxide. Number of bricks required for 1 cubic meter, that means 1 cubic meter. Calculate the volume of the single bricks. Standard size of the bricks are vary from one district to one district. Let us consider the standard bricks of 190 by 90 by 75 mm, that is 9 inches by 4 inches by 3 inches. This is an image of a bricks. This is what I call as a length. This is what I call as a depth. This is what I call as a width. Converting inch to meter for easier calculation. Total volume is equal to 9 inches by 4 inches by 3 inches, that is 0.2286 meter by 0.1016 meter and 0.0762 meter, which makes the volume of a single brick is equal to 0.00176980. Volume of each brick, as I said it earlier, it is 0.001769 cubic meter. Number of bricks in 1 cubic meter, 1 divided by 0.001769 will makes you 565 bricks. So we require a 565 bricks for covering a 1 cubic meter of a dry brick area. I am not talking about a brickwork. I am talking about a dry brick area. How to calculate bricks required in a wall of 10 feet by 10 feet. Bricks are joined together by using a cement mortar 1:6. We generally use 10 to 15 millimeter thickness between the layer of a bricks, the mortar joints. Therefore, the standard thickness of cement masonry layer in brickwork is 0.39 inches or at 10 mm. What I mean to say, when I say the brickwork mortar joint, this is the area I am talking about it. This is generally 10 mm we consider, that is a 0.39 inches. Adding mortar thickness to brick. Size of the brick 9 inches by 4 inches by 3 inches. add 0.39 inches to all sides of the bricks, which makes the size of the brick with mortar becomes 9.39 inches by 4.39 inches by 3.39 inches. See, let us see the image. This is a brickwork, that is a 10 feet by 10 feet. See, without a mortar, the bricks is 9 inches long and 3 inches depth. With mortar, it is 9.39 inches. To convert inches into feet, 3.39 inches. That is 0.78 feet by 0.36 feet by 0.28 feet. Consider area of a brickwork in calculating the number of bricks. For the given image, the area of the brickwork is length into depth, that is 10 by 10 feet, it is 100 square feet. Area of each brick, that is length and depth, 0.78 feet by 0.28 feet, which will make you 0.218 square feet with the addition of the mortar in all the three sides. RCC partly is provided at every 3 feet of a height of the brickwork. RCC partly has been provided every 3 feet. As per adjoining image, figure and length and height of the brickwork is 10 feet by 10 feet height. For a 10 feet height, there must be at least 2 partleys in the brickwork. See, look at the image. This is the brickwork. For every 3 feet, we had a partleys. That is, we call it the RCC bed, which might be ranging from 3 inches to 4 inches height. Dimension of the RCC partly brickwork calculation as follows. The length go up to the length of the brickwork and partly is connected to column to transfer the vertical load. Depth of the thickness of the partly may varies between 3 to 4 inches. Refer the figure. Let us consider maximum 4 inches, that is 0.33 feet. The length and depth of the partly is 10 feet by 33, that is 0.33. Area of partly is equal to length into depth 10 feet by 0.33 feet, that is 3.3 square feet. These are 2 partleys in brickwork, so 2 into 3.3 square feet makes you 6.6. Deduct the area of the RCC partly from the brickwork area. Therefore, for 100 square feet of the brickwork becomes 93.4 square feet of area after deducting the 6.6 square feet of the partly. Area of each brick 0.218 SFT. Total number of bricks 93.4 divided by 0.218, 428 bricks required approximately. So therefore, for a 10 feet by 10 feet wall with the 2 partleys, we require 428 bricks required. Cement ratio is 1:6. So the volume of the bricks becomes 0.022 into 0.1 by 0.07 will makes you 0.154 cubic meter. As we know that 0.39 inches is the mortar thickness is added to the brick size. Hence, volume of each brick with the mortar becomes 0.00228 cubic meter. Therefore, amount of mortar required for each brick 0.00228 minus 0.00154 is equal to 0.00074 cubic meter. From the above, number of bricks required is 428 bricks. Okay. Volume of mortar required is for 428 bricks is equal to 428 into 0.00074. That makes 0.316 cubic meter. Adding to the water to the dry mortar, it reduced by 33% due to bulkages and etc. So for a dry mortar, we have to add 33% to cover the dry to wet volume and as well as the voids. So dry volume of mortar is equal to wet volume of mortar multiplied by 1 plus 0.33, that is a 33% of volume. So dry volume of mortar is equal to 1.33 into wet volume of mortar. that is 1.33 into 0.316 makes you 0.420 cubic meter. 1:6 is the motor for a brickwork, which means cement and sand, 1 part of a cement and 6 part of a sand. Total parts is 7. Amount of required for a motor. The quantity of cement required for a brick motor is equal to dry volume of the motor into 1/7. That is 0.420 multiplied by 1 divided by 7 is equal to 0.06 cubic meter. Density of the cement is 1440 kgs per cubic meter, which means 1 m cube is 1440 kgs is required. For 0.06 m cube we required, for 0.06 m cube of motor we required 86.4 kgs of cement. Amount of sand is required for a motor. Similarly as a cement, sand is calculated in terms of cubic meter. The amount of sand required for a brick masonry, dry volume of a motor multiplied by 6.7, that is equal to 0.420 multiplied by 6 divided by 7 is equal to 0.36 cubic meter. In terms of kgs, density of sand is equal to 1600 kgs per cubic meter. For 0.36, we require 576 kgs of sand. Summary. For brickwork of 10 feet by 10 feet, where each brick size is 9 inches by 4 inches by 3 inches, we require without a motor 533 bricks. Requirement of bricks with motor 458 bricks. Number of bricks with RCC partly and motor is 428 bricks. The quantity of motor is required 0.42 cubic meter. Amount of cement is required 0.87 kgs. Amount of sand is required 0.36 cubic. Thank you for watching this presentation. Kindly subscribe, like and share, which will motivate me for a further good presentation. In case of any queries, do not hesitate to write to me. The response shall be at the earliest. Contact me at civilconclave@gmail.com or at my Telegram group, Ask Srini Telegram group. The link is provided as below. Kindly subscribe, like and share, which will motivate me to give you further good presentation.